In this lecture, we will try to understand about coterminal angles. Starting with the basics, how an angle is formed. Angle is formed when a ray OX is rotated about a fixed point O. Okay. So this is the ray OX, it is its initial position. Now we are rotating about fixed point O. So the ray OX is moved to this position and this is ray OY. Same ray we are rotating and this is the final position of the ray. And this is the angle formed. Now, angle is always measured from initial position to final position. For example, when I rotate initial position of the ray by 30 degrees, this would be my final position. Okay, or maybe I can rotate like this as well. This is initial position of the ray, I can rotate 30 degrees. So how do I distinguish between these two? Okay, here this is initial position, this is final position. Here this is initial position and this would be final position. So to distinguish between these two, I say the angle rotated is plus 30 degrees. Whereas here I say the angle rotated is minus 30 degrees. Okay, minus sign indicates clockwise 30 degrees. Means from initial position to final position, we have to rotate clockwise 30 degrees like this, clockwise. Alright. Whereas plus 30 degrees implies anti-clockwise 30 degrees. Means from initial position to final position, we have to rotate anti-clockwise 30 degrees. Suppose if nothing is mentioned, we have to take the rotation as anti-clockwise plus. For example, rotation of 60 degrees would be like this. This is initial position of the ray, rotate 60 degrees. This would be my final position. Rotation of minus 90 degrees would be like this. Okay, this is initial position of the ray, minus 90 degrees means clockwise 90. So clockwise 90 degrees. So this would be final position of the ray. Let me take a graph sheet. So it is general convention that we take initial position of the ray always along positive direction of x-axis. Okay. So suppose I have an angle 30 degrees. For this would be the final position. Similarly, there would be many angles for which I would be getting the same terminal portion. Suppose for example, let's take 360 plus 30 degrees. 360 degrees means one full rotation. From there, extra 30. 360 plus 30. Even for 360 plus 30 degrees, I would be having this one as the terminal position. Meaning what? 360 degrees, 30 degrees have same terminal positions. So whenever we have such angles for which we have same terminal positions, those angles we are calling them as coterminal angles. As the name suggests, coterminal angles means angles having same terminal position. Let's take graph sheet again. So we always take initial position of the ray along positive x-axis, and when I take plus 90 degrees, anti-clockwise 90 degrees, this would be my terminal position. Right? My final position or terminal position would be positive direction of y-axis. So I can say for 90 degrees, terminal position is along positive y-axis. So next time I will be using this language. 90 degrees represents positive y-axis. Okay, let's write few angles which are coterminal to 90 degrees. Okay, meaning I want terminal position along positive direction of y-axis. So what other angles would give me this terminal position? Of course, I can complete one full rotation and then rotate 90 degrees. So for 360 degrees plus 90 degrees, also we have terminal position along positive y-axis only. Meaning these two angles are coterminal. Like this, for how many angles I can get y-axis, positive y-axis as terminal positions? Maybe some of us will say, why one full rotation only? We can take two full rotations and then extra 90 degrees. So two full rotations mean 360 plus 360, which is 720 degrees plus 90 degrees. For this also terminal position would be along y-axis, clockwise 360, and then from there plus 90, minus 360 degrees plus 90. For this also terminal position would be positive direction of y-axis. Or we can go two full rotations anti-clockwise, so that is minus 720. From there, anti-clockwise plus 90. Then also we'll reach positive direction of y-axis. So minus 720 degrees plus 90 degrees. Okay, it seems that there are infinite angles for which I get positive direction of y-axis as terminal position. Okay, that means all these angles, whatever we have written, all these angles are co-terminal angles. So representing one terminal position, how many angles are there? There are infinitely many. All right. So for example, in this case we have discussed representing positive y-axis, how many angles are there? 90, 360 plus 90, 720 plus 90, minus 360 plus 90, minus 720 plus 90. If you observe, all these angles are in AP, arithmetic progression, with common difference 360 degrees. Okay, that is a nice observation to make. Now let's write all the angles which represent positive x-axis. The meaning of this statement is we want terminal position of the angles to be along positive x-axis. Of course, always we take initial position like this. We want terminal position also to be like this. So for what angles this happen? Of course, for 0 degrees, or we can make one full rotation. Then also initial position and final position would be along positive x-axis, 360 degrees. Or we can make two full rotations, 720 degrees. Or we can make one full rotation in anti-clockwise direction, which is minus 360 degrees. Or in anti-clockwise, two full rotations, minus 720 degrees. So for all the angles representing terminal position along positive x-axis or in this one. So there are infinitely many angles representing positive direction of x-axis. If you observe this, they are basically multiples of 360. All these angles, they are multiples of 360. Let me convert them into radians. 0, 360 degrees is 2 pi radians, 720 degrees is 4 pi radians. 2 pi is one full rotation. One full rotation in anti-clockwise direction. 4 pi means two full rotations. And 6 pi means three full rotations, 8 pi. And of course, minus 2 pi is minus 360 degrees. Minus 2 pi means one full rotation in clockwise direction, minus 4 pi, and so on. So all these angles are coterminal, and the terminal position for all these angles is along positive x-axis. Now if we notice all these angles, they are basically even multiples of pi, right? This is even number into pi. Okay, even number into pi, even number into pi, even number into pi. So how do we write all these angles? How do we represent all these angles just in a compact form? How do we write all these angles? So we say all these angles are in the form of 2n pi, where n is an integer. 2n means even number when n is an integer. 2n pi means even multiple of pi. So 2n pi is not just one angle. 2n pi is basically infinite angles. So if you want to get all these infinite angles, in place of n, you keep substituting integers. Suppose if you put n value minus 2, you will get minus 4 pi. N value minus 1, you will get minus 2 pi. N value 0, if you substitute. Only integers we have to substitute in place of n. We will get 0. N value 1, we substitute 2 pi. All these angles are basically represented by 2n pi. So we can say like this: all angles for which terminal position is along positive x-axis, they are in the form of 2n pi, where n is an integer. Again, 2n pi is not just one angle, it is collection of infinite angles. Okay, what is the speciality of all these infinite angles? The speciality is they have terminal position along positive direction of x-axis. Now, what about all the angles for which this would be the terminal position? Let's say this is 45 degrees. I want all angles for which this would be the terminal position. So how do we think about that? See, first we will try to reach positive direction of x-axis. Okay, how many ways we can reach positive direction of x-axis? Infinite ways. Okay, so suppose let's say 0 degrees we are here. For 0 degrees you add 45, you will be reaching this terminal position. Suppose 360 degrees we are along positive direction of x-axis. For that you add 45, we will be reaching this terminal position. Meaning we will try to reach here in all the different ways possible. From there, I'll add extra 45 to reach this particular terminal position. Okay, so all the angles for which this would be in the terminal position, 2 and pi, right? Even multiple of pi. Once I reach here, from there extra 45 degrees in anti-clockwise direction I can move to reach this terminal position. So this is 2 and pi plus 45 degrees. 2 and pi plus 45 degrees is basically collection of infinite angles, right? What is the specialty of these infinite angles? All these infinite angles are coterminal to 45 degrees. Means terminal position same as that of 45 degrees. So now I want all the angles which are coterminal to 90 degrees. So I want all the angles for which this is the terminal portion. So what is our strategy? First we will reach here, reach positive direction of x-axis. There are many angles which represent positive direction of x-axis, but they are all in the form of 2 and pi, where n is an integer, right? So once I reach here, in different ways, from there I travel 90 degrees in anti-clockwise direction to reach this terminal portion. Okay, all the angles for which positive y-axis would be terminal portion would be 2 and pi plus from there extra 90 degrees, pi by 2. Now we are going to find all the angles for which negative y-axis would be terminal position. Angles representing negative y-axis. That is, first we reach here. Angles along positive y-axis, positive x-axis would be in the form of 2 and pi. From there we are rotating clockwise 90 degrees. So this is 2 and pi reach positive x-axis, 2 and pi minus clockwise pi by 2. So 2 and pi minus pi by 2 will represent infinite angles. So, but for all these angles, positive y-axis would be the terminal position. Alright. What about all angles for which negative x-axis would be the terminal position? Okay, first we reach positive x-axis, that is 2 and pi. First we reach here, from there extra 180. Okay, so 2 and pi plus clockwise, anti-clockwise pi, where n belongs to z. So 2n plus 1 into pi. If I am taking pi common from here, we get 2n plus 1 into pi. So all angles for which this would be terminal position would be in the form of 2n plus 1 into pi, where n is an integer. We are saying 2n is multiple of 2, so it is even number when n is an integer. So then of course 2n plus 1 would be even number plus 1, right? For even number, if you add 1, the next number, that is odd number. So we have to know this translation. 2n when n is an integer in maths is even. Alright, in maths we say 2n plus 1, in English we say it is odd integer. Alright, so 2n plus 1 into pi means it is basically odd multiple of odd number multiplied to pi. It is odd multiple of pi. So let's summarize what I have discussed till now. All angles for which positive x-axis is the terminal portion would be in the form of 2 and pi, that is even multiple of pi. All angles for which positive y-axis would be the terminal position would be in the form of 2 and pi plus pi by 2, where n is an integer. For all angles for which negative y-axis would be the terminal portion would be in the form of 2 and pi minus pi by 2. All angles for which negative x-axis would be the terminal portion would be in the form of 2n plus 1 into pi, odd multiple of pi. So basically even number into pi. For these angles, terminal portion would be along positive x-axis. Odd number into pi. For these angles, terminal portion would be along negative x-axis. So for example, immediately we can say 33 pi. Since this is odd number into pi, 33 pi, terminal portion would be negative x-axis. For 98 pi, it is even multiple of pi, right? So terminal portion would be along positive x-axis. 37 pi by 2, let's say. Okay. For this angle, 37 pi by 2 means we start with initial position, rotate by 37 pi by 2. Where would be the terminal position? If suppose that question is asked, we can do it in this particular manner. 37 pi by 2 means it is basically nearest multiple of 2 here would be 36 plus 1 into pi by 2. So this is 36 by 2, which is 18 pi plus pi by 2. 18 pi is even multiple of pi, right? Even multiple of pi means positive x-axis. From there extra 90 degrees plus 90. So 37 pi by 2 for 37 pi by 2, terminal portion would be along positive y-axis. Alright. Similarly, if they say 19 pi by 2, we can understand it as it is 18 plus 1 pi by 2, which is 9 pi plus pi by 2. 9 pi is odd multiple of pi. Odd multiple of pi means negative x-axis. From there, plus pi by 2. Anti-clockwise. So that means terminal portion would be along negative y-axis for 19 pi by 2. So if we observe all the angles for which positive direction of y-axis or negative direction of y-axis would be terminal portions. The positive direction of y-axis, the angles would be in the form of 2n pi plus pi by 2. Negative direction of y-axis, angles would be in the form of 2n pi minus pi by 2. By substituting some values of n here and here, if we list out some angles representing positive and negative y-axis, they would be pi by 2. Put n value 1, you will get 5 pi by 2. If you put n value 2, you get 9 pi by 2. Alright. And here it would be, if you put n value minus 1, you will get minus 3 pi by 2. Similarly, if we substitute some values of n in here, we will be getting n value 0, minus pi by 2, 3 pi by 2, 7 pi by 2, 11 pi by 2, and so on. So if we observe all these angles and all these angles, if I place in one basket, what angles I am getting? Pi by 2, 3 pi by 2, 5 pi by 2, 9 pi by 2, 11 pi by 2. Similarly here, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. So if you observe all these angles, they are basically in the form of odd number into pi by 2, odd number into pi by 2, odd number into pi by 2. So all these angles are basically in the form of odd number, that is 2n plus 1 into pi by 2. So odd number into pi by 2 is representing angles along positive or negative y-axis. Okay, suppose if I say, for example, 37 pi by 2, 39 pi by 2, 97 pi by 2, and 13 pi by 2. So I can say all these angles, they are basically odd multiples of pi by 2. All these angles either would be along having terminal portion along positive or negative y-axis. Okay, if you ask exactly which one it would be, whether it is along positive or negative y-axis, then how to determine? For example, let's take 13 pi by 2. So 13 pi by 2, this is odd number into pi by 2. So definitely this would be along y-axis. Whether it is along positive y-axis or negative y-axis, how do we know? So again, we follow the same strategy. So we'll write 13 pi as 12 pi plus pi by 2, which is 6 pi plus pi by 2. 6 pi is angle along even multiple of pi, right? So 6 pi will be along positive x-axis. 6 pi plus pi by 2 would be an angle along positive y-axis. Now we know that this is angle along positive y-axis. Okay, same is the case with these also. So definitely they will be along y-axis, whether along positive or not, we can check like this. Okay, so what is the important point to note here? So one very important point here we understood. Whenever we have an angle which is odd multiple of pi by 2, right? So these angles represent y-axis, whether positive or negative, that is a different story. Odd multiple of pi by 2 definitely will represent, will have terminal portion along y-axis. Odd multiple of pi by 2 means either terminal portion would be along positive y-axis or negative y-axis. What about angles with terminal position along positive x-axis? They will be in the form of 2n pi. Angles with terminal position along negative x-axis, they will be in the form of odd multiple into pi. If they ask specifically terminal positions along y-axis, then we can say 2n pi plus pi by 2. They will be in this form. If they ask specifically angles representing negative y-axis, we can say they will be in this form, 2n pi minus pi by 2. Alright. What about angles along x-axis? If they don't mention positive or negative x-axis, okay, even number into pi means positive x-axis, odd number into pi means negative x-axis. If they don't mention anything, you can just say any multiple of pi. n pi, any multiple, whether n can be even or not, it will be along x-axis. Okay, basically if we club all these angles and all these angles in one basket, we will be getting multiples of pi. If we club all these angles in one basket, we will be getting odd multiples of pi by 2. Let's do one small exercise. So for this angle, what would be the terminal position? That would be, this is even multiple of pi, so positive x-axis. For this angle, what would be the terminal position? It is odd number into pi by 2. So we can just say it is along y-axis. Now if they insist whether it is along positive y-axis or negative y-axis, you have to do like this. So even multiple of pi is 6 pi plus pi by 2. So this is along positive y-axis. This is odd number into pi. So negative x-axis. So this is odd number into 90 degrees, odd multiple of 90. Terminal position would be along y-axis. Whether it is positive or negative, let's check. 27 pi by 2 is nothing but 26 pi plus pi by 2, which is 13 pi plus pi by 2. 13 pi is odd multiple of pi, that is here. 13 pi plus pi by 2 would be here. So here the terminal portion would be along negative y-axis. For minus 20 pi, minus 20 is also even number into pi, terminal portion would be along positive x-axis. Minus 13, which is odd number into pi, terminal portion would be along negative x-axis. So minus 91, which is odd number into pi by 2, so terminal portion would be along y-axis. So let's check whether it is along positive y-axis or negative y-axis. So minus 91 can be written as minus 90 plus minus pi divided by 2, which is minus 45 pi minus pi by 2. Minus 45 is odd multiple of pi, negative x-axis. Minus 45 minus means clockwise pi by 2. That is along positive y-axis. Okay. Now that we understood these important points, let's go a little bit further. So let's write all angles for which this would be the terminal position. So first we reach here, that is 2n pi. All angles for which this would be the terminal position would be in the form of 2n pi. From there extra 60 degrees. So all angles for which terminal position would be same as that of 60 degrees would be in the form of 2n pi plus 60 degrees. All angles for which this would be the terminal position. Same logic, first we reach here, that would be 2n pi. From there extra 150 degrees. So all angles for which this would be the terminal position would be in the form of 2n pi plus 150 degrees. Alright. Or there is one more way to think now. That is, first we can reach this terminal position, which is odd multiple of pi. First reach here, that is negative y-axis. From there go clockwise 30 degrees. So instead of writing 2n pi plus 150 degrees, we can also write this terminal position as odd multiple of pi minus 30 degrees. So both would mean same thing. Similarly, all angles for which this would be the terminal position would be in the form of, this is positive x-axis, so 2n pi. From there extra we have to travel 150 degrees. This 150 degrees is in clockwise direction. So all angles coterminal to this position would be in the form of 2n pi minus 150 degrees. This is one answer. Otherwise we can say, first we will reach here, that is, first we reach negative x-axis, that is 2n plus 1 pi, odd multiple of pi. From there we go anti-clockwise 30 degrees. So we can also write all angles having this terminal position would be in the form of 2n plus 1 pi plus 30 degrees. All angles for which this would be terminal position, this is 2n pi, and I want this as the terminal position, so it would be in the form of 2n pi minus clockwise 45 degrees. So all angles coterminal to theta would be in which form? So let's say for theta, this is the terminal position. For all angles having this as the terminal position, means you just need to add 2n pi to the theta. Okay. For theta, this would be the terminal position. For that you add 2n pi, means 2n pi plus theta will give you all angles coterminal to theta. So 2n pi plus theta, once again it is not just representing one angle, it is representing infinite angles How do you get all these infinite angles? By substituting different integers in place of n. What is common for all these infinite angles? The terminal position would be same as that of theta.